So 14C, problem number 1. Let me get there. What page is it on? 246. Okay. So we are dealing 2 cards. You win if the first card is the Ace of Hearts, or if the second card is the King of Hearts. So, if we had a large group of people, how many people would win because they have the Ace of Hearts first? 1 out of 52. So the chance that this is the Ace of Hearts is 1 out of 52. What's the chance that this is the King of Hearts? Well, there are 52 cards that could go there, and it's going to be 1 out of 52 because it's one of the 52 cards. We haven't said that the first card has to be a particular value. So it would be 1 out of 52. Now, if we said both, Ace of Hearts and King of Hearts, it would be 1 over 52 times 1 over 51. Is that the next question? So C, do any of the contestants step forward twice? Yes. There will be some people who have both. Are these 2 events mutually exclusive? No. Are they dependent? Is the second card dependent on the first card? Yeah, it is. Because the second card can't be the same value that was on the first card. Okay, true or false, and explain. The chance of winning a weekend in Philadelphia is 1 over 52 plus 1 over 52. False because there is overlap. They are not mutually exclusive. Some people will be in both winning groups. So a certain amount will win because they got the first card right, and a certain amount will win because they got the second card right, but there will be some people who won on both sides. Okay, number 2. A large group of people are competing for all expense paid weekends. Is this the same problem? First card is an ace, second card. If the first card is the Ace of Hearts or the second card is the Ace of Hearts. So we're going to change it just a little bit. First card, Ace of Hearts, or second card, Ace of Hearts. Okay? All contestants whose first card was the Ace of Hearts are asked to step forward. What fraction do that? 1 out of 52. Okay, everybody goes back. The ones who got Ace of Hearts on the second are asked to step forward. 1 out of 52. Check the back. Okay, good. Do any of the contestants step forward twice? No. Are these 2 events mutually exclusive? Can you be in both groups? No, because the Ace of Hearts in the first card prevents the Ace of Hearts being the second card. Does everybody understand that? So, letter D, am I allowed to add those probabilities? Yes. There is no overlap. So it'd be 2 out of 52, which is 1 out of 26. We are rocking. A deck of cards is shuffled, true or false. The chance that the top card is the Jack of Clubs is 1 over 52. Okay. The chance that the bottom card is the Jack of Diamonds is also 1 out of 52. Yes. Because every place has a 1 in 52 chance. It could be any one of the 52 cards. Okay. The chance, this is C, the chance that the top card is the Jack of Clubs or the bottom card is the Jack of Diamonds equals 2 over 52. So what it's saying is, can we add 1 over 52 to 1 over 52? No, why not? There's overlap. It could be both. Okay. Could the top be the Jack of Clubs and the bottom be the Jack of Diamonds? Yes. So they're not mutually exclusive. So we cannot add them together. E, the chance that the top card is the Jack of Clubs and the bottom card is the Jack of Diamonds equals 1 over 52 times 1 over 52. So we know that the first one is 1 over 52, right? I would say 1 over 51. What does the back say? Uh-huh. So you can't, oh yeah. You can't even do that because is the second one, we can use the multiplication rule when the second one is independent, but is the bottom card dependent on the top card? Yes. So there's a lot more going on here. That was C, right? Oh, sorry. D. The chance that the top card is the jack of clubs or the bottom card is the jack of clubs is 2 over 52. Sorry, D would be true. Does putting a jack of clubs at the top prevent a jack of clubs on the bottom? Yes, so we can use the addition rule. Okay, sorry. And then E was false. The chance that the top card is the jack of clubs and the bottom card is the jack of clubs is 1 over 52 times 1 over 52. False because they're mutually exclusive. They can't both happen. So if one happens, the other can't happen. So the probability would be, what's the chance that that card is on the top and on the bottom? None. It can't happen. You can't have the same card on the top and on the bottom. 4. The unconditional probability of an event is 1/2. The unconditional probability of event B is 1/3. Say whether each of the following is true or false and explain briefly. The chance that A and B both happen must be 1/2 plus 1/3. Or sorry, 1/2 times 1/3. So let's give an example of this. Oh no, it died. All right, let me draw that again. So, the probability of green is 1/2. Okay? The probability of 1 is, or no, it was 1/3, right? So we want to do 2. The probability of 2 is 1/3. Okay, this is one option. So look at A. The chance that A and B both happen is 1 over 6. In this case, is that true? What is the probability of green and 2? 1 over 6. Because only one of them satisfies that. But could I change the numbers and keep P of G and P of 2 the same? I could. What if I moved this 2 and 1? I switched places. Is the P of G still 1/2? Is the probability of getting green still 1/2? Yes. Is the probability of getting a 2 still 1/3? Yes. 2 out of 6. Okay. What is the probability of green and 2? Now it's 2 out of 6. Okay. So if we know the probability of A and the probability of B, is the probability of both of them going to be 1 over 6? Not always. It just depends on how it's set up. Oh, what does it say? Right. So, nope. I want this. Okay. So let's get rid of this and this and this. All right. So in this one, green and 2 are independent, right? The probability of getting a green is 1/2, and the probability of getting a 1, if you know that it's green, is the same. Or sorry, yeah, I said that backwards. The probability of getting a 2 is 1 in 3. The probability of getting a 2 if you know it's green is still 1 in 3, right? And the same is true with every other combination. Okay, but here it's different. The probability of getting a 2 is 1/3, but the probability of getting a 2 if you know that you have a green is now 2/3. So in this case, color and number are independent. And in this case, color and number are not dependent. Are dependent. Okay? So the idea of 1/2 times 1/3 requires independence. So in this case, it works because there's independence. But in this case, it doesn't work because there is dependence. And I really do apologize. I'm not very good at probability. My brain doesn't work that way. Yeah, well, and this book actually does a really good job. Other books are way worse. Okay, so we're on B. If A and B are independent, the chance that they both happen must be 1/6. True. C. If A and B are mutually exclusive, the chance that they both happen must be... If they're mutually exclusive, what's the probability that they both happen? They can't. 0. If they're mutually exclusive, then A prevents B from happening. So you can't get A and B. The best you can hope for is A or B. So it'd be 0. The chance that at least A or B happens must be 1/2 plus 1/3. That's only if they're mutually exclusive. The addition rule only happens if they're mutually exclusive. So, false. If A and B are independent, the chance that at least one of them happens is 1/2 plus 1/3. Nope, 1/2 plus 1/3 relies on not independence, mutually exclusivity. So you can only use the addition rule if they're mutually exclusive. Okay? If A and B are mutually exclusive, the chance that at least one of them must happen must be 1/2 plus 1/3. True. Okay. So the multiplication rule works if it's independent. The addition rule works if they're mutually exclusive. All right, 5. 2 cards are dealt off the top of a well-shuffled deck. Find the chance that the second card is an ace. So that second card could be, in order to be an ace, would be 4 out of 52 chances. Okay? Find the chance that the second card is an ace given that the first card is a king. It'd be 4 out of, not 51, 48.
It's just like what we talked about.
Oh, this. It really says 4 out of 52? Dang it. I.
So even though the first card's a king, you still got 4 out of 52 chances. 52 chances that the second card's an ace.
Oh, that is so hard to wrap my brain around.
It's still the whole deck. But the king doesn't. It doesn't mean you can't get an ace.
Yeah, I have a hard time with that. Okay, so
Because it's not an ace. It's not an ace, so it doesn't. Yeah, but it doesn't make your chances less. Your chance is still the same because it's not an ace.
wait a minute. C5B. Yeah, look at 5B says 4 out of 51. It doesn't. It says 4 out of 51. Oh, that makes me feel good. So the second card can be anything in the deck. If you shuffle a deck, the second card can be anything in the deck. But if you know that the first card is a king, then we've lost one option. We're not even sure which option we've lost, but we know it's not an ace. So B is 4 out of 51. That makes me feel good. Because it's a king.
Oh my god. So that 51 makes sense, but when they were saying 48, that...
Okay, so what we need to do is think of the deck as just shuffled. Right? In a shuffled deck, you have 51 or 52 possibilities for every place. So what's the probability that this is an ace? 4. 4 out of 52. Right? Any one of the cards could be there when you shuffle a deck. Okay, so the same is true of this card. 4 out of 52. But if we say this one is a king, now we've lost one of the cards. Right? So the next one would be 3 out of 51 for kings, but it's still 4 out of 51.
Because there's still 4 aces, but you don't have 52 cards.
Right. Okay. And when you shuffle a deck, any card could land in any spot. But once you start identifying spots, then you're working with dependence. Yeah, that's hard. That is hard to do. Yeah. So when we had the aces and the people stepping forward, okay, whether or not people stepped forward the first time, the other people may not have stepped forward. We were talking about different decks, right? It wasn't all the same deck.
See, that's what
Everybody had their own deck.
Oh, everybody had their own deck.
Yeah, everybody had their own deck.
One deck was passed out to everybody.
Yeah, everybody. Okay, that makes more good. If everybody has their own deck, then the second one will always be 1 out of 52.
Yeah, really.
All right. I hope that helps. Whew, this is hard. All right, and B, find the chance that the second card... Oh, we did that one. C, find the chance that the first card is a king and the second card is an ace.
4 out of 52 times 4 out of 51.
So that would be... The first one would have 4 out of 52, and the second one would have 4 out of 51. All right.